Every app on your phone, every website you've ever used, every database powering the internet is built on one simple idea you probably learned in your first week of coding and never thought about again. It's called an array, and understanding what's actually happening under the hood is the foundation for literally everything else in this course. Arrays feel simple. Store some values, access them by position, done. But most developers never learn what's actually happening in memory when you do that. And that gap is exactly what makes later concepts like hash tables and dynamic arrays confusing. So let's fix that now. An array is a block of memory slots sitting right next to each other, back to back, no gaps. When you create an array of 5 numbers, your computer reserves 5 consecutive spots in memory. That next to each other part is the entire reason arrays are fast. Because every slot is the same size and sits right next to the last one, your computer can calculate the exact memory address of any index using simple math. No searching required. ArrayNum doesn't scan through the array, it jumps straight there. That's why array indexing is constant time. Here's where arrays get expensive. If you want to insert a value at the beginning of a full array, every single element after it has to physically shift over one spot to make room. Insert at the start of a 10,000 item array, and you're moving 10,000 items. That's ON. In many languages, arrays have a fixed size set when they're created. Run out of room, and you can't just add more. You have to create a brand new, bigger array and copy everything over. This is exactly what dynamic arrays like Python list or JavaScript arrays handle automatically behind the scenes, silently resizing when needed. This is the pattern to remember. Arrays are excellent at reading by position, terrible at inserting or deleting in the middle. That single trade-off is the reason so many other data structures exist. Each one is solving a weakness that arrays have. Here's the mistake that trips people up in interviews: assuming all array operations cost the same. Reading array and inserting at array look equally simple in code, one line each, but they have wildly different costs under the hood. Always ask yourself where in the array you're operating the end is usually cheap, the beginning or middle is usually expensive. Arrays store data in consecutive memory slots, which makes index access instant, O1. But inserting or deleting anywhere except the end forces a shift, ON. That single trade-off between fast reads and expensive inserts is the foundation for understanding almost every data structure coming next in this course. This is video 5 of the full DevVerseX Data Structures and Algorithms course. Subscribe so this all clicks together in order. Next up, why array indexing is O1 and insertion isn't. We're going deeper into the exact mechanics behind what you just learned.